All right, these are the first set of notes, the 5.1 notes. So what you can do, because you don't have this packet in front of you, I would suggest just getting a notebook paper and writing down a few examples there. So the first part, we're going to write the expression in radical form. Radical form is another form for a root. So for our first example, we're going to take 10. It's going to go inside a root bar. Then the numerator, the 3, is going to go up at the top here. And the denominator, the 7, is going to become the root. So I'll write a little note about that. The denominator becomes the root. And the numerator becomes the exponent. And feel free to, if you need to stop this video, pause this video anytime that you need. All right, example number 2. We're going to take the 3. That's going to go inside the root bar. The 2 will go at the top, and the 5 will go in the front. Sometimes you'll see that number, the exponent, written on the inside, almost like this. That's the same thing. For number 3, we have the 11, the 1, and the 3. Now I want to make a little note about this 1 right here. This 1 actually doesn't have to be written. I can write my answer as just the third root of 11. The 1 is an exponent, is invisible. So let's let it write a little note. Invisible exponent of 1. So this 1 right there is often written, is often not written. All right, for example number 4, we have 6 on the inside, 7 up at the top, and 2 in front. Now this 2 is another one that is often invisible. There's an invisible root of 2. We call that root bar a square root, and square references the 2. So a lot of times you won't see the little 2 there. You'll just see the 6 and the 7, an invisible 2. Example number 5. You put your 5 on the inside. The 1 would go up at the top here. The 2 on the root here. But an invisible exponent of 1, you wouldn't have to write. And an invisible root of 2, you would not have to write. So you'll often just see that written as the square root of 5. No 1 needed and no 2 needed in front. All right. The next set we're going to do is we're going to go the opposite direction. We're going to rewrite these in exponential form. So you'll take the number that's inside. That becomes your base. And then the exponent, the 5, is your numerator. And the root, the 9, is your denominator. You write it as 16 to the 5/9 power. The next one, 5. The exponent goes at the top. The 8, the 3 goes at the bottom. Here, notice that there's nothing right here. So we have to think about what would be invisible. That's an exponent, so it's going to be an invisible exponent of 1. You have to add that in before you change it into a fraction. Otherwise, you don't have 2 numbers to create your fraction. I'll make a little note, invisible. All right. Example number 4. Notice again, there's no root in front. If there's nothing in front, it's an invisible 2. So we would write our answer as 3 to the exponent of 5/2. Now for example number 5, you actually have 2 things that are invisible. You have an invisible 1 exponent up here, as well as an invisible 2 root right there. So we would write this as 7 to the 1/2 power. Now, one thing about this section, I happen to use all numbers here. I used a 16, a 5, a 14. Delta Math uses X's. So instead of having numbers here, they have X's, but it's done exactly the same way. So I just wanted to point that out so it didn't confuse you when you got to your Delta Math assignment. The next thing we're going to do is express these in simplest radical form. So we're going to start by converting this into radical form, meaning put a root bar. The base number goes on the inside. The exponent is going to be the numerator, 5, and the denominator will be my root 2. You don't have to write the 2 if you don't want to, because that is one of your invisible root numbers. And we always want to focus on doing that part in the parentheses first. So the square root of 16, meaning what number times itself gets you 16. You could double check that in your calculator, or probably many of you know it in your head. The square root of 16 is 4. Then you bring over the exponent, and you just evaluate that. So in your calculator, you could do 4 to the 5th power, or you could just do 4 times 4 times 4 times 4 times 4. Either way, that gets you 1,024. All right, for the next problem, we have 64 to the 2/3 power. So we'll start by writing it into radical form. The top number goes up here at the top. The bottom number denominator goes on the root. And we focus on our parenthesis first. So what number times itself gets me 64? This is when I do my guessing and checking. So I try in my calculator, I do 2 times 2 times 2. That is not 64. So I try 3. 3 times 3 times 3. Also not 64. 4 times 4 times 4. There it is, that's 64. So the third root of 64 is 4. Because 4 times 4 times 4 is 64. Now this exponent of 2 we haven't used, so we bring it over. And then we evaluate 4 squared is 16. For the next one, example 3, we're doing 8 to the 1/3 power. So I'm going to start by writing it in radical form. The 1 up here, you could write, or you could leave it off if you want, because it's an invisible exponent of 1. The third root of 8, meaning what? Times itself 3 times gives me 8. So again, it's a little bit of a guessing and checking. I always start with my small numbers, 2, especially if the number is small. 2 times 2 times 2 is 8. So the cube root of 8 is 2. Then that 1 doesn't really do anything. You can bring it over if you want, or if not, you can just write your answer as 2, because 2 to the 1st is still equal to 2. The last 2 problems I want to do with you involve 2 exponents. So what we're going to do is we're going to start by combining those 2 exponents. So you have 81, and then you have 3. I'm going to go ahead and put that 3 over 1 to make it look more like a fraction, so that it's more lined up with my 1/4. And then I'm going to multiply my numerators together, 3 times 1. I'm going to multiply my denominators, 1 times 4. And now I'm back to a type of problem I know how to do. I'll put the 3 and the 4. And then we'll do the 4th root of 81. 2, 3, 4. What number 4 times is going to make 81? That's going to be 3. Bring over the exponent of 3. And 3 to the 3rd is 27. Our last problem for today. I'm going to again start by writing 1/2, and then I'm going to write 5 as 5 over 1. And I'm just going to need to multiply that together. So numerators, 1 times 5 is 5. Denominators, 2 times 1 is 2. And then from there, you can write it as a root, 5 and 2. The square root of 9, which you could also just write as the square root of 9, no 2 necessary, but that would be 3. And then 3 to the 5th power. Take your calculator, multiply 3 times 3 times 3 times 3 times 3. That would give me an answer of 243. If you have any questions, please contact me. I would love to help.